Okay. I think I'm here today because 1 year and 2 weeks ago, I made an apology in front of 600 farmers in Oxford. And the apology that I made was for making the greatest mistake in my life, which was to oppose transgenic crops. And not only did I oppose them, I myself tried to eradicate them. So, in these pictures you can see, that one over there is me. And if I think back to what changed my mind, this was a conversion which was based on evidence, on scientific evidence, which I had to collect myself over many years. Because what I opposed in terms of transgenics, when this happened, this was in the 1990s. Okay, this was a new technology. Potentially this was a dangerous technology. So we were moving genes across the species barrier from bacteria into canola, which is what that crop was. And of course, people were concerned that there could be unintended consequences. And those concerns were not irrational. I think they were justified at that time. However, the way that science advances is through evidence and through the accumulation of evidence over many years of studies. You don't see evidence presented against transgenics though. The evidence is emotional, it's visual. It's the corn with big teeth, or it's the deformed babies. The pictures that we've just seen made me feel sick inside because they have nothing to do with transgenics and they should not be being used in this context. Now, my expertise, as has been pointed out, is not as a biochemist or a molecular biology or a molecular biologist or as a geneticist. My interest has always been in climate change. And I think climate change illustrates well how we generate knowledge through the scientific method. Nobody experiences the changing average temperature personally. We can only have it properly understood through the accumulation of data, such as these NASA visualizations, which show how the temperature, the average temperature, has increased from satellite measurements, from thermometer measurements, millions of pieces of data all being put together to form the bigger picture. Now, data can also be illustrated by anecdotes. And anecdotes are reasonable and are useful when they do illustrate a scientifically definable trend. For example, for my first book, I was in the Peruvian Cordillera Blanca. These photos have now become quite famous because they were used in Al Gore's film An Inconvenient Truth. The photo on the left was taken by my father, who is a geologist, working in the Cordillera in 1980. The photo on the right we took when we went back there. And of course, the glacier has disappeared, but how do we know that this actually illustrates climate change? Because we know from satellites and from other scientific measurements that the same process is happening throughout the Cordillera. It's happening here in Chile, in the Andes as well. It's happening in the Alps. It's happening in the Himalayas. It's happening on the polar ice caps. And we know that this is symptomatic of the average temperature of the planet rising. We also know that the impacts of that will be profound. We will see the sea levels rising because the snow that is melting from the mountains, the ice that's melting from the polar ice caps, goes into the seas, raises the overall average sea level. And for people who are living in low-lying countries, islands like here in Tuvalu, you can already see, because they're only this high above the sea level, and so every year the extra 3 millimeters of global average sea level rise, to them this has a serious impact, and it's already coming into their houses. Already the waves are washing into their islands.
threatening the future of the country. Now, a lot of people point out that I'm not a scientist. You shouldn't believe what I say, and I agree with them. I'm not a scientist. I'm a graduate of politics and modern history from the University of Edinburgh in 1995. But the greatest thing that happened in my life was discovering science. And so I had to because I'm from a humanities background, I had to become self-taught on even the very basic stuff, what science is, different statistical methodologies, what peer review is, what the academic literature means, what value that has, what scientific consensus is about. And this was where I did it in the Radcliffe Science Library at Oxford University, and the second book I published was called 6 Degrees. This book had 600 scientific references. And when I published it, I found myself under attack from all these people who called themselves climate change skeptics. I would call themselves climate change deniers because they were denying the overwhelming scientific evidence about the reality of global warming and the danger that it poses to humanity. If we see temperatures rise by 6 degrees this century, then the planet will have changed utterly and irrevocably. It will be completely transformed from the planet that we have grown up in and that our human civilization has developed in. And as I say, I found myself in conflict with climate skeptics. And even they even had their own scientists. They would say, no, I have a scientific article, just like you saw now. But these studies were cherry-picked. The scientists themselves, there were 4 or 5 scientists out of several thousand who were always the same scientists who were cited. And so I would always come back to this issue about scientific consensus. And yet at the same time, I was being personally inconsistent. I wrote this in The Guardian, the UK newspaper, in 1998 against biotechnology. This was 1 year after I had finished publishing my pro-science climate change book called 6 Degrees. So I was personally, I have to be humble about this. I was inconsistent on scientific issues for many years of my life. And it was a difficult thing to try to resolve, especially when I was appointed climate change advisor to President Nasheed of the Maldives. And so I was personally responsible for giving scientific advice to a head of state of a vulnerable country. In fact, that was the last time I was here in Santiago, was representing the President of the Maldives in the climate change negotiations that the UN was taking place, and we were being hosted here in Santiago to take those negotiations forward. And again, let's look at the language that the scientific community is using on climate change. How do we know that the climate skeptics are wrong about this? As I said, none of us personally experience changing average global temperature. That's impossible. So we have to essentially look at what the community of experts has agreed. And they would say the scientific evidence is clear. Global climate change caused by human activities is occurring now and has a wide variety of impacts from, like I just showed you, melting glaciers, destabilizing ice sheets, rising sea levels and more extreme weather. And they also, by the way, make a policy statement in this document saying the time to control greenhouse gas emissions is now. So scientists can also influence policy, and they need to acknowledge that that is the case. This statement, by the way, was produced by the AAAS, which is the American Association for the Advancement of Science, the preeminent scientific institution in the United States, and some would say the world. Now look at the next statement I could show you from the same scientific academy, this time on biotechnology. The science is quite clear. They're using the same words. Crop improvement by the use of modern molecular techniques of biotechnology is safe. And they cite the World Health Organization and various other academic institutions who have reached the same conclusion. Consuming foods containing ingredients derived from GM crops is no riskier than consuming the same foods containing ingredients from crop plants which have been modified via conventional techniques. And of course, as you saw in one of the earlier slides projected here, this is a scientific consensus not just of Americans, but of every single scientific academy in every single country in the world. How can you ignore the combined assessment of these experts? And when I was just in Africa, 9 African academies of science were represented in a meeting in Addis Ababa. This was about 2 months ago. Overwhelming global scientific evidence shows that plant products which are GMOs are as safe as their non-GMO counterparts. Hence, African countries shall encourage research and utilization on GMOs. Biotechnology can have a significant and positive role in meeting Africa's dire need for more food to tackle hunger, malnutrition, and underdevelopment. This is not all just about multinationals planting large-scale monocultures in the United States. There's a whole other dimension to this technology which the activists against it would never dare to reveal to you. And the other good thing about science is that bad science, eventually, after a year in this case, this was retracted, the Seralini so-called study, because the methodology that he had used, this was pseudoscience, this was propaganda, was found to be flawed. Retracted the study has no validity, except in Kenya, when this study came out, in Kenya, the Minister for Public Health, she'd just been suffering from cancer. And the activist told her that her cancer came from eating GMOs. And so when she saw these pictures of these rats with big tumors, she persuaded the president to impose a ban on GMOs in Kenya. Now this study's been retracted, and Kenya's still left with a ban. They can't change their policy. And this has real-world impacts, serious impacts for the livelihoods of African people. This is a photo I took myself in Tanzania. I was there traveling with support from the Bill and Melinda Gates Foundation. And one of the greatest challenges which affects food security in this part of East Africa is a virus disease called cassava brown streak virus, which affects cassava, which is the staple crop of smallholder farmers and families across the whole region. And this crop, this virus, it gets into the roots, it turns them brown and it rots them and it destroys the tubers under the ground which these families depend on. And you can see in the background, this is the same place, different family. These kids are hungry because the cassava plants, the cassava crop is failing because of this viral disease. You can see how the plants in the background are all stunted, they're beginning to shrivel up because of the viruses which are affecting them. There's only one way to control this virus. You can't control it with sprays. You can't control it like a pesticide or something. The only way to control the virus, which has yet been discovered, is the transgenic version. So this is a really interesting technology. It uses RNA silencing, pathogen-derived resistance. And essentially what happens is they took the coat protein from the virus itself, inserted it into the genome of the cassava, and that gives the cassava resistance to the virus when it's deployed in the field. And it should be completely safe because the sequence which is put into the cassava doesn't express the protein in the plant. So the only thing which has changed about the plant is the genetic sequence itself. So there's no novel proteins, there's no concerns about toxicity, allergenicity, or any of these things which are always mentioned. And if you look at these, okay, this isn't scientific, this is anecdotal, but look at the plants in the background, look how healthy they are. This was in Uganda, and these were the healthiest cassava plants I saw in my whole time in East Africa. But what chance have the farmers got of actually getting these plants? So this is a field trial behind a big fence, as if this was somehow threatening, as if these transgenic plants were somehow a kind of germ warfare, rather than something the scientists have derived which can actually benefit people's food security. So in Uganda, the activists now are fighting against biosafety regulations. So this crop can never be released. In Tanzania, there's a strict liability clause which is so strict that no scientist would ever dare use a transgenic crop. So those hungry people that I showed you in East Africa have no access to these crops because of the misinformation and the myths and the regulatory overload, which is strangling biotechnology, not just in Africa, but in other parts of the world as well. And where does all of the misinformation come from? Well, it comes from NGOs who derive their funding from European sources. And yet none of them were transparent. They would all say to me, oh, Lynas, you're funded by Monsanto, right? This is a constant allegation which is made to me, for which there is no proof because it's not true. But they couldn't tell me who was funding them. The money comes from all sorts of official sources. And yet what it's doing in Africa is directly undermining food security and preventing farmers, preventing smallholder farmers from being able to make choices themselves for their families. In Uganda, for example, an NGO called Action Aid, which is a British organization, which has a mandate to reduce poverty, their activists made photoshopped pictures of corn with babies' heads coming out, and they showed this to farmers in the fields, farmers who don't know Photoshop, right? These people don't have computers. They're subsistence-level farmers. And they use religion. So they took pictures as well, and they went into a Muslim area in Uganda, and they said, the scientists, they're using pig genes, and they're putting pig genes into your bananas as a threat to your religion. And they almost caused a riot, and the scientists themselves and the MPs who were supporting them found themselves attacked. So why is this kind of thing allowed to persist, and why is it supported by NGOs who should have respectability? I also been to, very recently, this was only 2 months ago, to West Africa. This is in Ghana, and this guy here is the director in charge of a trial of Bt cowpea. So the pest that they have in Ghana affecting cowpea, which is very serious, it's called maruca. It's like a lepidopteran pest, so it's like a caterpillar which goes into these peas and destroys them, and the farmers can't afford the pesticides, which is the only other way to control that pest. And so they're using the Bt protein, which is very specific. It only targets that insect. So when you hear that Bt or the cry proteins are toxic, well, they're only toxic if you're an insect, and only a particular type of insect. For everyone else, they're completely non-toxic. And this could transform the prospects in this part of Ghana, because this is the most important protein crop, because people don't have access to animal proteins, if they can protect it for farmers to use. And perhaps one of the things that most struck me was in Zimbabwe. These students from the University of Zimbabwe, again, I took this picture. They were showing me how they were doing transgenic work themselves in the laboratory. Now, in Zimbabwe, the government is officially anti-GMO, a kind of a conspiracy theory of big Western multinational corporations, a bit like you just saw in the earlier presentation. And that's the official government policy. And so what do these students do? They have no money, but they know there's serious challenges for their crops. So they went to the rubbish dump in the town. They get the jam jars, because they have no laboratory equipment. They wash them and sterilize them, and they do the genetic transformations with cling film wrapped around the top. They bring up water, because the taps don't work. They bring up water in buckets from 3 floors down. And when the generators fail, they have to try and keep them cool to keep the process working. And these are students who are aged 20, 21, 22. You heard about the Agrobacterium tumefaciens, which is used. They even got this from the soil outside the laboratory. So they start completely from scratch. There's no multinationals, there's no patents, there's none of this stuff that you hear about. This is almost being done in the backyard by these students. And what they're trying to do is to transform for virus resistance for yam, for sweet potato, which is another major threat to the crop in Zimbabwe. Early on, you heard some lies about golden rice. Well, I've actually been to the trial site. I've been to the University of the Philippines. in Los Baños, near Manila. And this is me in the golden rice greenhouse. So what they're doing here is to take the genetic event which allows the production, the expression of beta-carotene in the rice, and they're putting it into the local varieties which are adapted to the climate of the Philippines and which the farmers prefer to use. Because this rice can only work if farmers are out there and they're growing it for themselves, for their families, in the fields. And that bottle of rice on the left, that would be enough for half of the daily need of a child. And you heard earlier on that it's taken a long time for golden rice to get out there into the fields. Well, it didn't help that it keeps being attacked, that it got destroyed by activists who came in taxis which were paid for by an NGO. They came all the way from the cities. They put a press release saying that farmers were rebelling. These guys are not farmers. Farmers don't have red hair, they were saying. These people came from the cities. They destroyed the whole golden rice crop. And in fact, farmers would never do this because they have a cultural, taboo on destroying green rice plants. So no farmer would ever destroy a rice plant in the field. And I looked into their funding, and do you know where the funding came from? For this NGO, it came from the Swedish government, from SIDA, Swedish International Development Agency, who also fund IRI. So they fund both sides. They fund the scientists to make the golden rice, they fund the activists to destroy the golden rice. How much sense does that make? And actually the scientific community was so outraged by the vandalism and the attack on the golden rice crop that they published a statement in Science, an editorial statement which was unprecedented in the use of the language that they were using. If ever there was a clear-cut cause for outrage, it's the concerted campaign by Greenpeace and other NGOs against golden rice. And look at the figures here. Severe vitamin A deficiency results in blindness, and about 500,000 children who are blinded by it die within the year. So the total death toll associated with vitamin A micronutrient deficiency is about 2 million preventable deaths annually, mostly of children under 5, and also of pregnant women. And they tell us this is a technology which has no value. They try to stop this technology being deployed into the fields where it can be saving lives now. Why is golden rice not available now to farmers? Because it has to go through the regulatory system. I had an email from the director of IRI, and now they're going to have to try and put golden rice through the European regulatory system. Otherwise, there will be contamination. And the whole rice trade will shut down because of rice, which is a little bit yellow, because it's got a tiny bit of beta-carotene in it, to try to save some lives of young children. This makes no sense. It doesn't make sense scientifically, and it doesn't make sense even more so morally. Now, I speak to you as an environmentalist. I'm an environmentalist who wants to see the reduction of the use of agricultural chemicals, those which are toxic. For example, in European farming, cultivation, we grow a lot of potatoes. The primary pathogen for potatoes is what's called late blight. And its effects are so serious. Remember, this is the disease that caused the potato famine in Ireland in 1850, which killed 1 million people. And the effects of this blight are so serious that it destroys the whole crop. So what do farmers do? Well, they spray with fungicide every single week, or every 2 weeks in a good year. Otherwise, the potato crop ends up looking like that. So how can biotechnology help? Well, scientists in 4 countries have already developed a blight-resistant potato. These are not Monsanto scientists. These are scientists employed by universities in the public sector aiming to do something which can improve environmental outcomes. These potatoes are in field trials. But how can farmers ever use them in a continent like Europe, which prohibits farmers from having the choice of what technologies to use, and totally prohibits the deployment of anything which is considered transgenic, with a single exception of some maize in the south of Spain. And here's one which is even more interesting. Again, this is public sector research in the United Kingdom. Scientists at the Rothamsted Research Institute have succeeded in getting camelina to express omega-3 long-chain fatty acids, which you can only otherwise get from fish oils. And why could this help sustainability? Well, because one of the major threats to biodiversity is overfishing. One of the solutions to that potentially is aquaculture, so growing salmon or other fish, as happens here in Chile. But what is used to feed the salmon? Well, mostly it's other fish. So if you can grow land-based feedstocks using this transgenic technology, then you can have a sustainable supply of feed for fish, and you can begin to take some of the pressure off the biodiversity in the oceans. Now, that's something which may or may not be deployed in the future. This is at the research stage. But let's look at something which has already happened and which has already been deployed. You heard the story of the Hawaiian industry for papaya, how this was saved in the 1990s by the same kind of viral resistance technology which is now being employed in Africa for cassava. So this is essentially where it was developed. This is pathogen-derived resistance using the coat protein of the virus being papaya ring spot virus, which devastates the whole crop, as you can see on the right-hand side of that one. So the transgenic crop was 100% resistant. And just when the Hawaiian papaya industry was about to be destroyed completely by the virus, the scientists brought in for free these seeds, and it saved the industry overnight. So pretty much 70–80% of the papaya which is now used in Hawaii and which is exported to the United States and Canada and elsewhere and Japan is transgenic. And it's the same papaya, it has the same nice taste and everything, but it doesn't have the virus because it's been made resistant. Now, papaya is grown in many more countries than just Hawaii. So it would have been nice if the same scientists employed by the same universities, one of which is Cornell, which I'm currently associated with. In Thailand, it was stopped by Greenpeace in 2004. They also revealed that some of the seeds had already been taken out of the research station and were already being grown by Thai farmers for papaya. Why were the farmers doing this? Because they wanted papayas which were healthy and which weren't being destroyed by the virus, and they wanted to get there quickly. But there was a huge media scandal which Greenpeace... And for my last example, this is something which is very dear to my heart, something I'm personally working on at the moment with Cornell University. And we're launching a BT variety of brinjal, berenjena? Yeah, eggplant, in Bangladesh, where it's the most important, pretty much the most important agricultural vegetable crop. And it has the same problem of pest infestation, which is such a serious problem. And they don't use the more benign pesticides that they try to use in Western countries. They use the worst kind of old-fashioned organophosphates type varieties, which have serious impacts on farmers' health. So guess how many times average farmers spray their brinjal eggplant crop in an average growing season? Take a guess. Huh? 20. Anyone got more than 20? 40. Huh? No, up, more. 120. So they spray every single day because they grow the crop in the rainy season and the rain washes it off. And the option of using BT means that the protein which is toxic to the insect is expressed within the fruit. So when the insect goes in, it kills the insect and the fruit is protected. Now, I began to change my mind on this issue a few years ago, really when that last article was written in 2008. But I kept quiet for a long time because I recognized that I was not an expert. I recognized I hadn't read the scientific literature on biotechnology and on transgenics. But when I wrote this book called The God Species, I wanted to focus on all of the major ecological challenges which face the planet over the century to come. Namely, we have biodiversity loss. So we're seeing dramatic losses now for every animal kingdom, plants as well, birds, the marine environment. The biodiversity crisis is there with climate change as the most critical ecological challenge facing us today. And what is the primary cause of biodiversity loss? Agriculture, farming. And what's the main reason why this happens? Because of habitat loss. Another major effect is the use of fresh water. This is a critical issue here in Chile. We're seeing, because of climate change in this country, a reduction probably of rainfall in the subtropical areas. We're seeing the disappearance of the mountain snows and the glaciers and the nevados because of climate change. So where will the water come from that we need for agricultural production in a country which is important agriculturally? Well, we need to look at ways to reduce water consumption. And there's many different technologies which are employed to reduce the amount of water used in irrigation. Transgenics is just one tiny proportion of that. Maybe we can help with having drought-tolerant crops. I would never say that GMOs are the answer to any of these problems. They're a part of a possible solution. We need to explore and we need to see how valuable this tool is. Nitrogen use. So why do we have a dead zone in the Gulf of Mexico covering 20,000 square kilometers in an average summer? Because all of the nitrogen which is being put onto the US corn crop runs down the river Mississippi, causes eutrophication in the oceans, and that has a devastating effect. So how can we begin to reduce nitrogen applications in world agriculture? Well, you know, there may even be a transgenic solution if we can get major cereal crops to fix their own nitrogen, just like leguminous crops do. And I talk about planetary boundaries, and probably the most important one for biodiversity, for agriculture, for food is the issue of land use. If we had continued to use the technologies of 1960 and we'd seen no improvement in productivity for the last 40, 50 years, there would be no rainforests, either in Brazil or in Indonesia. But in actual fact, we were able to increase productivity. And that has saved the environment probably more than any other single human innovation. But looking into the future, the human population will continue to grow. We're looking at 9.5, 9.6, 9.7 billion by 2050. And yet already we're seeing a leveling off of productivity, even at least in cereals production. So the gap between the population growth and the production of major agricultural commodities is beginning to expand. Well, how can we address this? You know, I think the solution is going to be from many different areas. It's going to be improving agricultural practices. It's going to be deploying more irrigation, because when I was in Africa, almost no one has access to irrigation because it's capital intensive. It's going to be employing more fertilizer in parts of sub-Saharan Africa where they have no fertilizer and they have very low productivity. We need to increase food production by 70 to 100% by 2050 to feed the increasing population, and an increasingly wealthy population, because these countries in Africa now have high rates of economic growth, and they expect their populations to have much lower rates of malnutrition. That means they need to eat more food. And so we could call this the next green revolution. It's been called the doubly green revolution because it would be a revolution in sustainability as well as productivity in global agriculture. So let's not make any mistake. I have just as many concerns about monocultural, agrochemical dependent production on the prairies of the United States as everyone else does. I'm concerned about the chemical use, the water use, the nitrogen use, the pesticides use. All of that concerns me enormously, which is why we have to look to the scientific community and to agronomists to bring us the solutions which farmers can then deploy. We cannot have misinformation and myths stopping scientists from doing their legitimate work. And before he died, Norman Borlaug, who was the father of the Green Revolution, left us with a very strong warning. He said that if the opponents of biotechnology manage to succeed, they might actually end up causing the famines and the crisis of global biodiversity that they've been predicting for nearly 40 years. So I'm here to tell you today that I changed my mind because I didn't want to see that happen. And I hope all of you here who are farmers, who are in the scientific community, will stand up against the myths, against the misinformation, and you'll stand up for what you know to be true and for what you believe in, which is to improve the sustainability of agriculture and to produce enough for more people on the planet, which we hope can continue to flourish for the next century. Thank you very much.